Have you ever been sitting in a doctor's office under those really awful fluorescent lights, just staring down at one of those standardized medical
Oh,
checklists?
I know exactly the ones you mean. They're the worst.
Right. And you're just looking at these little boxes, trying to rate your, extremely messy, highly complicated human experience on a scale of 1 to 5.
Yeah, like rate your internal chaos from rarely to very often.
Exactly. Like, how often do you feel restless or how often do you interrupt? And you just know, sitting there with that clipboard, that this piece of paper is completely failing to capture the reality of how your brain actually works.
Because it is. I mean, we are essentially asking patients to take the infinite complexity of their inner lives, their unique cognitive struggles, and just squeeze all of that into a very rigid binary framework. It completely strips away all the context.
It really does. And for decades, that is exactly what diagnosing ADHD has looked like. But today, we are going on a deep dive into a massive, groundbreaking shift in how we understand this condition.
A very overdue shift, honestly.
Oh, completely overdue. We are pulling from this incredible 2026 article in Psychology Today by Dr. Russell Ramsey. It is titled, beautifully, I might add, Let's Ask Brains What ADHD Looks Like.
I love that title. It captures the exact pivot the scientific community is finally making right now.
Yeah, so our mission today is to explore this monumental shift. We are talking about moving completely away from those subjective, often incredibly frustrating symptom checklists and moving toward mapping the literal, physical, structural networks of the brain itself.
Which is huge.
It is, because this research takes something that is deeply personal and, let's be honest, often misunderstood by society, and gives it a tangible physical shape.
Before we jump into the new brain mapping revolution, though, we really have to look at the fundamental flaws in the current diagnostic system. We need to understand why relying on that behavioral checklist is a dead end, particularly for adults.
Yeah, we all know the standard breakdown. You're either slapped with an inattentive label, a hyperactive label, or, a combined one. The current diagnostic standard relies on a list of just 18 symptoms. 18.
It's remarkably short when you think about it.
Divided neatly down the middle between those inattentive and hyperactive behaviors. But clinicians have known forever that this is incredibly messy in practice. ADHD is notoriously heterogeneous.
Highly variable. If you take 10 people with an ADHD diagnosis and put them in a room together, you are going to see 10 completely different sets of daily struggles.
Oh, absolutely.
Like one person might be completely immobilized by executive dysfunction, just staring at a blank screen all day.
Yeah.
But another might be a highly successful CEO who just impulsively talks over everyone and cannot regulate their frustration.
And the 18 symptom checklist forces both of those incredibly different human realities into the same exact restrictive boxes.
Exactly.
And reading Dr. Ramsey's article, it becomes glaringly obvious that the checklist is fundamentally broken when it comes to adults. I mean, the original criteria were really designed around children and adolescents.
9-year-old boys in a classroom, specifically.
Right. And the demands of an adult life, managing a mortgage, navigating complex emotional relationships, organizing a career trajectory, those are fundamentally different from sitting still in third-grade math class.
The way the condition manifests structurally and behaviorally changes as the brain ages, but the diagnostic manual just hasn't fully caught up.
The studies Ramsey cites highlight empirically based adult symptoms that are completely missing from that main 18-point list. Things like cognitive inflexibility, disinhibition.
Emotional dysregulation is a huge one.
Yes, emotional dysregulation. One research effort, he points out, even produced a distinct 9-symptom list that heavily features executive functioning difficulties. Those are massively underrepresented in the current standard criteria.
And when you ignore those adult-specific symptoms, you end up with a really high rate of misdiagnosis. Or you get patients who are told they don't meet the criteria simply because their primary struggle is, say, emotional regulation, rather than tapping their foot during a meeting.
Okay, let's unpack this, because as I was reading about these checklist limitations, a visual came to mind.
Oh, I love a good visual.
So, relying on an 18-symptom behavioral checklist to diagnose something as complex as adult ADHD feels like trying to diagnose a complicated car engine problem by standing in your driveway, closing your eyes, and just listening to the noises the car makes.
Just listening to it idle.
Yeah, you just stand outside the car, you hear a rattle, you check a box for rattles, you hear a squeak, you check a box for squeaks, but you are never actually popping the hood to look at the machinery.
Oh, that analogy hits the nail on the head.
Hmm.
Behavioral checklists only show us the outward effects the noises the engine is making. They completely ignore the root mechanical causes.
Right.
And because entirely different mechanical failures can produce the exact same outward rattle, grouping patients together based purely on those outward symptoms is scientifically imprecise.
You group all the rattle cars together, even though one has a bad transmission and the other just has a loose license plate.
Exactly. You're categorizing the symptom, not the source.
And when you categorize the symptom instead of the source, the treatment is going to be completely misaligned.
It has to be. You might prescribe a generalized stimulant to someone whose primary issue isn't alertness, but rather a structural inability to switch tasks.
Which brings us to the hood finally being popped. Researchers realized they needed a completely new way to measure ADHD. They needed to look at the physical hardware of the brain itself.
This leads us to the innovative study published in JAMA Psychiatry by Pan and colleagues in 2026.
Now, this study focused on children, but as Dr. Ramsey points out, understanding the structural root is going to have massive direct ramifications for how we handle adults. And the sheer scale of this study was huge.
Yeah, the numbers are impressive.
They completely threw out the symptom questionnaires for their analysis. They used structural brain scans, MRIs. They had 446 children in a discovery group and another 554 in a follow-up validation group.
And they were comparing all of them against children without ADHD. The methodology here is what makes it so revolutionary. They weren't looking for broad, generalized brain activity.
Right, they were getting really specific.
Highly specific. They were tracking complex metrics across the structures of the brain to map how they function within larger networks.
Here's where it gets really interesting, though. Because I have to admit, I was looking at this JAMA methodology and I got a bit lost in the technical weeds.
It is very dense.
Yeah. So they used MRIs, not fMRIs, right? So they aren't looking at real-time blood flow or dynamic brain activity. They are taking static pictures of the physical structure, like an X-ray of a bone.
That's right.
So my question is, how on earth do you get dynamic networks and measure efficiency from a static photograph?
That is the brilliance of morphometric similarity.
Morphometric similarity. Okay.
When researchers look at these structural MRIs, they aren't just looking at the size of a brain region. They're looking at tissue density, cortical thickness, and folding patterns.
Like the actual physical topography of the brain.
Exactly. By mathematically comparing those structural features across different areas of the brain, they can infer connectivity. It is based on the principle of structural covariance.
Meaning what, exactly?
Basically, regions of the brain that wire together and work together tend to physically grow and shape themselves in similar ways over time.
Oh, wow. So even from a static image, the physical shape and density of the tissue leaves a permanent footprint of how those regions communicate.
Precisely. It's a structural footprint.
Right.
And they use that footprint to measure three distinct metrics: degree centrality, nodal efficiency, and the participation coefficient.
Okay, to make sense of those three metrics, I built a mental model for myself. I started picturing the brain like a massive, sprawling city's traffic grid.
I like where this is going.
Let's take degree centrality. That roughly translates to the number of connections a brain region has. So in my city grid, degree centrality is the number of intersecting roads at a major junction. A high degree centrality means it's a major hub, like Times Square.
A structural hub where a massive amount of cognitive traffic is routed. That works perfectly.
Right. Then there's nodal efficiency, the efficiency in signaling. So in the city, that's the speed limit and the actual flow of traffic through those intersections. How fast do the cars actually move?
In neurological terms, poor nodal efficiency might mean that a localized area of the brain is incredibly sluggish at processing information. The roads are there, but the traffic lights are totally out of sync.
Which means you might get stuck on a thought or struggle to process a complex instruction.
Exactly.
And finally, the participation coefficient. This is how well those regions communicate with entirely different functional networks. So these are the massive suspension bridges connecting entirely different boroughs. It's not just local traffic, it's getting the data from Manhattan to Brooklyn.
Let's apply that bridge analogy to a real ADHD symptom. If your participation coefficient is low in a specific area, it's like the bridge connecting your visual processing center to your executive functioning center is bottlenecked.
So you visually see the messy room, you know it's messy, but the signal to initiate the physical task of cleaning gets stuck in traffic on the bridge.
You literally have the information, but your brain cannot send it to the department that takes action.
That is wild. You just don't have the bridge capacity.
It is a perfect translation of the science. The researchers used these three metrics, the hubs, the traffic flow, and the bridges, to develop what they call morphometric similarity networks, or MSNs.
Essence, got it.
They mapped out these individualized networks across the brain structures to examine variations and influential coupling patterns.
What's fascinating here is how the authors actually applied this data, because they didn't just look at the ADHD brains in a vacuum. They took these individualized MSN city grids and compared them to a non-ADHD control group. And the authors explicitly liken this comparison to a pediatric growth chart.
Just as a pediatrician plots a child's height on a curve to see where they land compared to population expectations, these researchers compared individualized brain network data against the neurotypical controls.
Right, to see the deviation.
They weren't looking for a generalized ADHD brain. They were looking to see exactly where a specific individual's traffic grid deviated from the expected structural norm.
And the results from that first discovery group of 446 children were completely confirmed in the follow-up validation study of 554 children. This wasn't just some statistical fluke.
Replicability is the absolute gold standard in structural neuroimaging.
So they map out these complex brain city grids, they compare them to the non-ADHD growth charts. And they didn't just find one messy, generalized pattern of deviation. The data organically clustered into entirely distinct physical profiles.
3 emergent biotypes.
This is where we really leave the behavioral checklist in the dust. The data revealed 3 biotypes of ADHD, defined not by what the kids were doing outwardly, but by what their physical brain networks were doing inwardly.
The first pattern that jumped out from the data biotype 1 represents a severe combined profile.
And this group manifested highly elevated, persistent symptoms. And structurally, it was deeply tied to emotional dysregulation. The data even showed a greater likelihood of mood disorders organically tied to this specific network deviation.
It provides a physical basis for why so many individuals with ADHD simultaneously struggle with profound emotional volatility. The structural hubs regulating mood and the hubs regulating attention are both physically dysregulated in this specific biotype.
So what about the classic hyperactive presentation? You know, the kid who literally cannot stop moving, or the adult who compulsively interrupts conversations.
That leads us to biotype 2.
Yeah.
The scans reveal that these predominantly hyperactive and impulsive behaviors are driven by dysregulated action mode networks in the brain.
Okay, let's define the action mode network for a second. What does it actually do in a healthy brain?
The action mode networks are essentially the brain's idling engine.
The idling engine.
Yeah, they prime your motor systems and cognitive systems to respond to external stimuli. They prepare you to move, to react, to catch a ball thrown at you.
So if that network is structurally dysregulated, if the traffic flow is jammed or the bridges are sending the wrong signals, your brain is constantly hitting the gas pedal even when you're just supposed to be sitting quietly in a chair.
The machinery driving the physical action is running without the proper structural brakes.
That makes so much sense. It really does. And then we have the daydreamers. The people who are chronically inattentive, who zone out during conversations or lose their keys 5 times a day.
Biotype 3. The scans showed that this predominantly inattentive group is driven by interference in the default mode network, or the DMN.
I've heard of the DMN. That's the network that handles our internal monologue, right? Like daydreaming, self-reflection, thinking about the past or the future.
Exactly. In a neurotypical brain, the default mode network is highly active when you are at rest. But the moment you need to focus on a complex external task, like doing a math problem or listening to a lecture, the DMN is supposed to power down.
It just switches off.
The structural bridges signal it to turn off, so the brain's executive networks can take over and do the work.
So if there is structural interference in the DMN...
It doesn't power down.
Yeah.
It stays online, blaring background noise while you are trying to focus. It's like trying to listen to a crucial phone call while someone next to you is blasting a radio.
The traffic jam on the bridge is keeping the daydreaming network active when it's supposed to be dormant. Wait, I have to pause here. Because we need to really grasp the magnitude of what this JAMA study just proved. Is this simply a high-tech medical way of renaming the old behavioral subtypes? Like, is biotype 3 just fancy neurological jargon for the predominantly inattentive presentation we've always known about?
If we connect this to the bigger picture, it is an entirely new paradigm. Think back to your car analogy. Before, we were literally just saying this car belongs in the rattle group based on noise.
Yeah.
Now, we are saying this car belongs in the structural default mode network interference group. Biotype 3 isn't a description of a person getting distracted. It is a defined, measurable physical disruption in a specific brain network. We have finally connected the symptom of inattention directly to the mechanical brain wiring that causes it.
That is staggering. To be able to point to an MRI scan and say, right there, there's the structural, mechanical reason you cannot sustain your attention right now.
It changes the conversation entirely.
Which brings us to the real-world emotional impact of all this. Because understanding the hard physical roots of these three biotypes completely reframes how society should view this condition.
Well, for a century, the symptoms of ADHD were heavily moralized.
Yes. If you look at the medical history, it was dismissed as bad parenting. It was labeled as laziness or a character flaw or just a lack of willpower. And Dr. Ramsey emphasizes how much damage that history still does today. He writes that ADHD is a valid, distinct, and highly nuanced diagnostic syndrome. It affects lives seriously, and it demands evidence-supported treatments.
He explicitly targets how it is perceived culturally, too. The trivialization of the condition by cartoonish social media presentations.
The whole look squirrel meme culture.
Yeah, exactly. When society reduces a complex structural brain difference to a quirky meme about getting distracted by a squirrel,
Yeah.
it does immense psychological damage to people genuinely struggling to manage their daily lives.
So what does this all mean? Consider what this means for you, the listener. Whether you have ADHD or you suspect you might, or you just want to deeply understand human psychology. Think about the profound emotional weight of this discovery. To sit in that doctor's office, completely frustrated by an arbitrary 18-point checklist, feeling like you were just fundamentally failing at life. And then to hear that your struggles are rooted in measurable, physical, structural brain networks.
The biological validation completely removes the stigma of a moral failing.
It's not a character flaw. It's not that you just need to buy a better planner or try harder to pay attention. Your default mode network is experiencing physical interference. Your action mode networks are structurally dysregulated. It is biology. It is hardware, not willpower.
This raises an important question about the future of medicine, though. As Dr. Ramsey notes, we are still in the early stages of understanding all the clinical implications for how we treat these specific biotypes. But this subjective validation demands that the medical community take ADHD seriously as a condition requiring highly sophisticated, targeted care. We can no longer dismiss it as a modern behavioral quirk or blame it on smartphone addiction.
We have the receipts now. We literally have the MRI structural maps showing the traffic jams.
It forces a total reevaluation of our clinical approach.
It is just a massive leap forward. Let's look at the incredible journey we've taken today. We started with a rigid, outdated behavioral checklist that completely missed the nuances of adult life, missing major symptoms like cognitive inflexibility and emotional dysregulation.
We moved from that subjective guessing game to the objective reality of structural MRIs, mapping out morphometric similarity networks. We look at the hubs, the traffic flow, and the suspension bridges of the brain.
And that data led organically to the discovery of three distinct physical ADHD biotypes. The severe combined with emotional dysregulation, the hyperactive driven by action mode networks, and the inattentive driven by default mode network interference.
It is a total transformation. We move from diagnosing a noise in the driveway to analyzing the exact mechanical failure under the hood.
But before we go, I want to leave you with a final thought to chew on, something that builds on everything we've just discussed about the future. If we can now literally see ADHD as specific physical network disruptions, if we can look at a scan and see the exact traffic jam on a specific bridge in your brain, could the future of treatment move entirely away from generalized behavioral medications?
It opens up an entirely new frontier for psychiatric intervention.
Right. Instead of taking a generalized stimulant pill that just floods your entire nervous system, could we eventually use advanced neurotechnology like targeted transcranial magnetic stimulation to actively rewire or stimulate those exact specific physical hubs? What if we could fix a transmission directly instead of just turning up the radio to drown out the rattle?
The potential to treat the exact structural source rather than managing the chemical symptoms is profound.
It changes everything. Thank you so much for joining us on this deep dive. Keep questioning your assumptions, keep looking past the simple checklist, and keep exploring the fascinating, messy mechanics of the human brain. We'll see you next time.